the lesson for Chapter 2, Section 7, Dilations, day number 2. So let's take a look at our first type of problem that we're going to see. It says that the blue figure is a dilation of the red. So blue dilation of the red. That means that this is our image. The blue is the image. The red is the pre-image. And so whenever we're talking about a dilation, we need to know which one the image is and which one where we start. That will determine whether it's an enlargement or a reduction, telling us whether our scale factor needs to be smaller than 1 or bigger than 1. So when I look at this also, I can see that because of this little prime sign, see that little mark right next to the X there, that tells us that this is the second figure here after it's been modified. So I see that this is a reduction in size. It's a reduction because it started big and now it's getting a lot smaller. So let's find out what that scale factor is. So when I try to find the scale factor, I look at the size. Let's take a look at xy. This is 2 units. See, 1, 2. So x prime to y prime is going to end up being 2 units. And if I look at this one, from x to y, this one ends up being 1, 2, 3, 4, 5, 6, 7, 8 units. And so how did they go from 8 to 2? That's what they're asking. 8 and then times what number would equal 2? Well, it must be a smaller number. It must be something below 1 but bigger than 0. And it's a quarter. So if I take a quarter of 8, a quarter of 8 is 2. So basically I'm dividing by 4 in this problem, and that will be that solution. So the scale factor, and sometimes they'll end up using a variable k for the scale factor, equals 1/4. So taking a look at this one, we are going from the red to the blue, and I can tell that because that little mark right up here next to the J, these are the second figure, or the image of this, and when I look at this, notice how the M to L, if I count the spaces, well, first of all, we see that it's going to be an enlargement, because it's going from a small to a bigger one. Now, if I look at the units here, I got 1, 2, 3, 4, 5 units. So M to L is 5 units. And when I look at this one, I go 1, 2, 3, 4, 5, 6, 7 and a half. So L prime, or M prime to L prime, is equal to 7 1/2. Well, how do I figure out how much it changed? Well, what I can do is I can, since I know it's a reduction, or an enlargement, I'm going to go ahead and put the 7 1/2 on top and the 5 on the bottom. So what I can do from here is change this to an improper fraction. So 7 times 2 plus 1 gives me 15 halves. And I'm dividing by 5. Well, when I divide, that's the same thing as doing something like this, using this symbol here. And when I divide by fractions, I'm really multiplying by the reciprocal. So when I go ahead and do that reducing, I get 3. So 3 halves is the number I'm looking at. Another way to do that is just to divide 5 into 7 and 5/10. So I can change that 7 1/2 to 7.5, and let's see what happens. See, 5 goes into 7 one time, with 2 left over. And then I bring the decimal up, 5 goes into 25 5 times, so there it is. 1.5 is the same thing as 3/2. However, when we're using scale factors, we like the fraction form because it's easier. It tells us what to multiply by, what to divide by, and so I'm going to use that as my scale factor. So the scale factor equals k, which equals 3 halves. Well, let's take a look at the next type of problem we'll see. It says the vertices of a figure are given, and it says find the coordinates of the figure after the transformation is given. So when I do this, I could draw the picture, but if you know the rules, it makes it a little bit tougher. We went over those in class, and so I'll go over the rule for each of these problems that I have. So my rule for reflecting across the y-axis goes this way. So if I go across the y-axis, this is the y-axis, notice how the x values change, but the y value doesn't when you reflect. So what you write is negative x comma y. So what you're going to do is you're going to take these points, and if I have negative 5, 3, you're going to change that, and so it's going to change to 5 comma 3. And then I need to, it says dilate with respect to the origin with using a scale factor of 2. So what that's going to look like is this: 2x times 2y. So I take that value and I'm going to double it. So when I double 5 and double 3, I end up with, in this case, 10 comma 6 is what I get. And so that's going to be what A double prime is. And so I'll do the next one. So that was A. Let's take a look at B. And so B starts at negative 2, 3. Well, again, that's going to change to 2 comma 3. And then I'm going to double each of those terms. So when I double the 2, I get 4. If I double the 3, I get 6. And that's going to be that value. Let's take a look at C. C started at negative 2, 1. And what it goes to? Well, it's going to end up going to 2 comma 1. And when I go ahead and double those values, we end up doubling the 2, we get 4. Double the 1, we get 2. And the last one there, D, was negative 5, 1. And I'm going to reflect it, so that's going to switch the x value, keep the y value the same, and then double those values to find out what D double prime is. So that's going to be 10 comma 2. So that's all you have to do for finding the coordinates, is what it says, and those are what the coordinates are. Here it says dilate with respect to the origin using a scale factor of 5. So my formula is going to go this way: x comma y. I'm going to dilate with the scale factor of 5, 5x, 5y. And then I'm going to then dilate with respect to the origin with a scale factor of 0.5. So I'm going to take that answer, and I'm going to take a half of that answer, and take a half of the next one. So let's see what we get here. So we've got P started at negative 2 comma 2. So when I multiply it by 5, I get negative 10 comma 10. But then I need to take half those numbers, and when I take half of those, I end up at negative 5 comma 5. Is that first one. That value was P. So I'll put P double prime there. And when I take a look at the next one, Q started at 4 comma 2, and I multiply it by 5, I get 20 comma 10. And when I go ahead and find out what that value is, Q double prime is going to end up being 10 comma 5. I take half those numbers. And then R started at 2 negative 6. And so when I multiply those by 5, that gives me 10 comma negative 30. But then I need to take half those numbers to find out what R double prime is. And that's going to be 5 comma, and then take half that and makes negative 15. And the last one there, S, and that starts at negative 4, negative 6. And when I go ahead and multiply those by 5, I get negative 20 comma negative 30. And then I got to take half those numbers. That gives me S double prime. So that's going to be negative 10, negative 15. So those are the solutions I'm looking for there. And let's take a look at the next type of problem. Last one says the red figure is similar to the blue figure. Describe the sequence. Sequence means more than one. So we're going to have more than one transformation in which the blue figure is the image of the red. So this is the image, this is what we're trying to make. So we can see that it's an enlargement. And so that helps us figure that the amount of dilation needs to be bigger than 1. So let's start with the first thing that we're going to do. And I see that this figure needs to go to the other quadrant, but it needs to not only just reflect there, it needs to actually turn into that spot. So that's what I'm going to do first. I'm going to rotate about the origin, I'm going to rotate about the origin 90 degrees, and I want to go counterclockwise because that'll move it into that second quadrant there. So when I do that, this point right here is going to go here, and then this point, remember, it's going to follow this y-axis. So it's going to come down here, and if it's 2 spaces over and 3 spaces up, it's going to flip. So it's going to be 3 spaces and then 2 spaces up. And so that point's going to be down over here. we'll put that point right here. So 2 spaces to the right, 3 spaces up is going to be 3 to the left, 2 spaces up. And this point is 3 over to the right, 1 space up, so let's reverse that. 1 over, 3 up. And the last one there, this is 4 spaces over, and that is 3 spaces up. So let's go 3 over and 4 up, and we get our point there. So now we've got the image going the right direction. Now we just need to make it the right size. So when I look at it, look at this unit right here. This is 2 spaces, and this is 4 spaces. So I need to enlarge by 2. Enlargement with a k equals 2. So let's do this. Let's go ahead and dilate with, actually we'll say about the origin first, with a scale factor of 2. So let's see where that puts us. Let's go ahead and write down what those points are. This point here is going to end up being, we'll call it negative 1, 1. So when we double those points, it becomes negative 2, 2. So that point ends up going right here. So that matches. That's good. I'm going to change the color there so it's a little bit easier to see. So let's go ahead and change it to blue. How about that? So blue right there. And then this point here was negative 1, 3. So when I double that, it becomes negative 2, 6. And that matches this point. So that's good. This point here was negative 3, 2. So when I double that, it becomes a negative 6, 4. So let's go ahead and plot that over 6 spaces up 4 spaces. That matches. And the last one is this point. It is 3 to the left and 4 up. So negative 3, 4. So when we go ahead and double that, we get negative 6, and double 4, we get 8. And that does match this point as well. So once we've done that, we've got our sequence. And there it is. So those are the types of problems you'll see on tonight's homework. Good luck.